Displacement reaction. See, these all are last minute examination preparation tips. These are also one type of chemical reaction where, for example, AB is a substance that was reacting with the C. After the chemical reaction, BC plus A has formed. That means C has displaced B. Displacement. Initially, understand this equation. Initially, B was with A, and after the chemical reaction, B was with C. That means the position of B has changed. That is called displacement. The reaction in which the position of one element has changed. Such type of reactions we call it as displacement reaction. In order to write about the displacement reaction, first of all, you should know about the reactivity of the metals. That's most important. Without knowing the reactivity of the metals, you cannot write the products formed during a chemical reaction of displacement. It's very important to know about the reactivity series. What do you mean by reactivity series? Generally, all the metals do not have the same reactivity. So, we have arranged the metals in the descending order of their reactivity. What do you mean by descending order? Highly reactive metals to less reactive metals. If you don't know the reactivity of the metals, it's not possible for a displacement reaction to write the products. During a displacement reaction, one element will displace other one. Right? Before writing the products in a displacement reaction, you should know about the reactivity of the metals. So first let me explain the reactivity series. How the metals were arranged in the descending order of their reactivity, that is called reactivity series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, gold. Like in between, hydrogen also will be present. At that I kept it as brackets because clearly, like completely, we cannot consider hydrogen as a metal. But the reactivity of hydrogen also we have to mention in a reactivity series. That means potassium is highly reactive element and gold is less reactive metal. Actually, these all are metals. So, potassium is a highly reactive metal and gold is less reactive metal. If you know the reactivity series, then only you can able to write the products. For example, let's take an example. That is, copper sulfate solution is there that was reacting with iron. So what are the products formed in this reaction? Is this is really an example of displacement or not? See, copper sulfate solution which is blue in color. Right? It's a blue color solution. To that we have taken iron nails have taken into the solution. After some time I observed that the blue color has disappeared because iron has displaced sulfate. That means FeSO4, iron sulfate has formed and copper is liberated in this reaction. That means iron has displaced copper in this reaction, because if you observe that iron, position of iron in the reactivity series is here and copper is here. This indicates that iron is more reactive when compared to the copper. So, a highly reactive metal can displace a less reactive metal to give products. This reaction is known as displacement reaction. Now, I will write the reverse reaction. That means iron sulfate was reacting with copper. What are the products formed? Generally, children will do mistakes here only, because copper sulfate was reacting with iron, then product here obtained is iron sulfate and copper. So, while seeing this equation, you understand that iron has displaced copper from its position. It's clear. Now, I wrote the reverse reaction. Now, iron sulfate solution is there and we have added copper turnings to the iron sulfate solution. Now, what changes do you observe? You don't observe any changes. Here we'll write no reaction. Displacement cannot be possible here. But many children will do mistake like that. They'll write copper sulfate and iron will be written here as products, which is a wrong concept. Because why the reaction? There is no reaction. Why there is no reaction when copper turnings were added to iron sulfate? That's why I told first only, in order to write a displacement reaction, first you should know about the reactivity series. Observe copper. The position of the copper is at the bottom, iron is on the top. That means iron is highly reactive than copper. Less reactive metals cannot displace highly reactive metals. It's not possible. It's less reactive when compared to iron. That's why here no reaction. You cannot get copper sulfate and iron in this reaction.